All right, spiral time. Spirals are interesting because what we're going to do is we're just going to let r equal t in this situation. Obviously, you could have different forms of this. You could have 2 times t, which is representing 2 theta, 1/2 times t, 1/2 theta. But just think about if you make r equal to t, think about the graph of that. I mean, it's really like saying y equals x. You're talking about a line with a slope of 1 that's increasing every time we sub in a larger value for x. Well, this is similar to some extent because every time you sub in an angle, think about pi over 2. Whatever pi over 2 is as a decimal, that's going to be your decimal value for r. So these two you're going to see are going to just grow and continue to grow, and the larger theta is, the further away you go, which is why these don't have a maximum r value. They don't have symmetry because you're seeing this constant change in your r value, and it's going to keep getting larger and larger and larger and larger, and it never returns back to smaller amounts. Even if you change and you put you put a 1/2, let's just use parentheses just because I don't know how this is going to register it. I can't talk. True story, I'm due for my coffee right now, and I'm trying to get through these notes so I can get to my coffee. So you and these videos are the only thing keeping me from where I really need to be right now. So anyway, if I change it, notice it's still going to grow, but at a slower rate. So notice that when I get to pi, or 2 pi, it's really only the equivalent of being pi units away. You'll see you're hitting 3.14 there because it just slows down the growth of that spiral.